Next lesson, we're going to be looking at box plots, which is a way of displaying our data. But before we can do that, we have to be able to gather some information to help us draw that box plot. And so the information that is required is this thing called the 5-point summary. The only 5 things that we include in our 5-point summary is the minimum value of the data, which is the lowest value of the data, the 25% mark, which is the Q1, the median, which is Q2. Remember, the median is the middle or the 50% mark. The upper quartile, Q3, which is our 75% mark. And the last thing there is the maximum value, the highest value in the data. They are the only 5 things in our 5-figure summary. Now, we can put our data into our calculator, and following the instructions there, we can come up with these 5 things that we can read straight off. Make sure that you are at the Teams meeting so that you can see me go through this. Interquartile range is a term that you will hear quite often now. So what is the interquartile range? Well, here it tells us that it is Q3 minus Q1, the upper quartile minus the lower quartile. Let's put that into simple English. And the simple English is that it is the middle 50% of your data, because it's your 75% mark minus the value at your 25% mark. So it's the spread of the data from the 25% mark to the 75% mark, the middle 50%. One other thing that we have to know before we get onto box plots is what an outlier is. I often use the example of a class that I had a couple of years ago where it was, I think, a year 11 class, and everybody in there was, between 175 and probably about 180 centimetres tall. Yet I had one student in there who was going to be a footy player, and he was already 199 centimetres tall. And I had another student that was going to be a jockey, and he was 155 centimetres tall. So they didn't fit into the main body, the main height or the average height of the students in there. So they are considered to be outliers. They are not in the main body. So we do have a way of being able to work out outliers. Again, our calculator will show us what an outlier is, but we do need to be able to work it out. So what we're saying here is that Q1 minus 1.5 times the IQR is how we would work out our lower post or our lower boundary. And anything that is smaller than that value in our data would be considered an outlier. So that is our post, and anything lower than that would be an outlier. Our upper post is worked out by Q3 plus 1.5 times the IQR. And again, anything that is bigger than that is also considered to be an outlier. Anything in between those two values is not. So let's put this into action. The following data set represents the number of flying geese spotted in each day of a 13-day tour of England. So we have 5, 1, 2, 6, 3, 3, 18, 4, 4, 1, 7, 2, 4. So they were all spotted on individual days. Now, we're asked to find pretty much the 5-point summary here: the minimum, the maximum, the medium, the upper and lower quartiles. So that's our 5-point summary. And then the last thing is to find the IQR. All of this should be able to be done on your calculator. So we'll put everything into our list and spreadsheet and work it out from there. And when you put it into your calculator, we get the minimum is 1, the maximum is 18, median or Q2 is equal to 4, the 25% mark, the lower quartile, Q1 is equal to 2, and our upper quartile, which is Q3, is equal to 5.5. So they're the things we can read off the calculator. The IQR, we can use information from the calculator in order to be able to get it. So here it's Q3 minus Q1, which in this case is 5.5 minus 2, which is equal to 3.5. So that should not be overly difficult, just reading information from your calculator. Now the next part of the question wants us to find the outliers, and we do need to show the working out. So let's start with the lower bound. And remember, anything smaller than this is going to be an outlier. So what was the rule for lower bound? It was Q1 minus 1.5 times the IQR. Now we've worked out what Q1 and the IQR are, so let's put that information in. So we get 2 minus, and it's bracket 1.5 times 3.5. We can put that all into our calculator and we get negative 3.25. Now let's look back to our values. Is there anything in our original data list that is smaller than negative 3.25? Well, no, because we don't have any negative values. So therefore, there are no outliers on that side. So now we need to check for outliers on the upper side, or the upper bound. And what was our rule there? It was Q3 plus 1.5 times the interquartile range. So let's fill that in. This case we get 5.5 plus 1.5 times 3.5. And again, all into your calculator, you get 10.75. Let's look back to our data. Are there any values in that data which are bigger than 10.75? And if you're looking properly, you will see that 18 is bigger than 10.75. So therefore, 18 is considered to be an outlier. So there is only one outlier, and it is on the upper bound side. It is 18. Now the last question is not particularly mathematical, it's just getting you to think about what the information is telling you, or come up with perhaps some suggestions as to why you got an outlier. Now remember, the outlier is saying that there were 18 geese spotted that day, and that was not really the norm. So why do you think that 18 geese might have been spotted? Well, you could come up with a multitude of reasons. One reason could be that a flock of geese was actually spotted that day and they were flying across, and so 18 geese were counted, rather than on other days where they were flying in maybe groups of 2 or 3. So you come up with your own suggestions as long as they are feasible. My other thought was perhaps there are more geese in some locations in England more so than others, because remember, this was a tour of England and they were moving around. So that's another feasible reason.